So hi everyone guys, welcome to yet another video session with PrepBytes. I'm Swapnil and in this video editorial I would be discussing the problem prime dish of the February marathon 2021. Now the problem statement goes like Cole is a foodie but he can only eat the food if its tastiness is a prime number. I would be noting down all the important times parallelly so that it would be easier for you to understand. So the first important point is he can eat only if tastiness is a prime number. Now, the food is numbered from 1 to n. Okay, food is numbered from 1 to n. The tastiness of the food increases by 1 unit every day. Tastiness increases by 1 every day. Each day, he checks if the tastiness of the food is a prime number, then he eats it. Each day, he eats all the food with tastiness as a prime number. This is what it meant. Now, if there are multiple such foods in a day, then he eats them in increasing order of their index, which means that he eats multiple food in increasing order of their food number. Okay. Now coming to the input format, the first line will contain T, which is the number of test cases, and for each test case, there are two lines of the input. The first line contains the number of food n, and the next line contains n integers t1 t2 up to tn, which means the tastiness of each and every food. Okay, coming to the output format, for each test case we will have to print a single line in which we will have to determine the order of food eaten by Cole. That's what the task of this problem is. The constants are t is ranging from 1 to 10, n is ranging from 1 to 10 power 5, and the tastiness values can range from 2 to 6 into 10 power 6. The time limit for solving this problem is 1 second, and this is the sample input and output. Moving to the coding area to discuss the sample input and output. Okay, so here when n is equals to 5 and the tastiness array is 3, 5, 4, 17, 9, the food numbers are nothing but 1, 2, 3, 4 and 5 for the food with these tastiness values. So on the first day, Cole eats A1, A2 and A4, which is nothing but the food with tastiness 3, the food with tastiness 2 and the food with tastiness 4, because these are prime numbers. And then on the second day, this A3 becomes 5, right? Because every day it increases by 1 unit. So this A3 becomes 5 and this A5 becomes 10. Now that the A3 has become a prime number, Cole will eat this A3. Okay. Now on the third day, A5 becomes 11 because on the second day A5 became 10. On the third day it will become 11, and now 11 is a prime number. So Cole will eat A5 now. So the order is first A1, then A2 and then A4 and then A3 and then A5, means 1, 2, 4, 3, 5, which is the required output. Now, what is the funda to solve this particular problem? How exactly we will be encountering this problem? Okay, so you can see that here it's related to prime numbers. So, like, there must be your first idea to solve this problem should be to go with sieve operation, which is nothing but calculating the primes till a certain number or a certain value n. Okay, now it's pretty simple that we just have to subtract all the tastiness values from its nearest prime number greater than equals to that value, right? What does this exactly means? You will get it by this table. Let's just say this is the food number and this is the tastiness value. So for tastiness value 3, the prime number which is greater than or equals to this particular number or this particular tastiness, it is nothing but 3, and for 5 it is 5. For 4, the nearest prime greater than equals to tastiness is 5. For 17 it is 17 because 17 is a prime number, and for 9 it is 11. Now the difference between this particular number, the nearest prime number, and the tastiness values would be 0, 0, 1, 0 and 2, right? So the ones with difference as 0 would be the one Cole would be eating on the first day itself because they are already prime number. And then after 1 day he would be eating the one with difference as 1 because after 1 day the value of tastiness would be increased by 1, so the difference would become 0. And after the second day he would be eating the one with difference as 2, right? That was the scenario over here which we discussed. So now we will have to map these differences with these particular food numbers, okay, and print them in ascending order of their difference. That's what the question asks us. Like for zero difference we have food number 1, 2 and 4. For the difference 1 we have only food number 3, and for the difference 2 we have only food number 5. And then for these differences we would be printing them in increasing order of the differences. So first the ones with zero difference, which is nothing but 1, 2, 4, and then the ones with one difference, which is nothing but 3, and then the ones with two difference, which is nothing but the food 5. So this is the order, right? Now the question is, how will we like find the prime number that is greater than or equal to a certain tastiness value? That is, how are we getting this section of my table, right? This must be a question. So it's pretty basic that if prime is our only concern, then Sieve is the answer. Now, how are we going to apply Sieve? We will pre-compute Sieve for 6 into 10 to the power 6, which is nothing but 6 triple zero triple zero, and then I'm also adding 100 over here because I just want to find the total number of primes for a certain number which is greater than 6 into 10 power 6. So you can use any of it, but I have used 6 into 10 power 6 plus 100 to get all the prime numbers stored in a certain array. So this pre-computation is giving me the array which is storing all the prime numbers till this value. Okay, this sieve operation is giving me. For sieve operation you can watch any of the videos. It's really very simple, just a mathematical concept, that's it. Now we will use binary search to find the prime number which is greater than equals to a certain tastiness value, right? So after this operation I have got an array primes which is storing all the prime numbers, right? And our task, what we want to find is to get a number, or basically get a prime number which is greater than equals to a certain number x, and x is the tastiness value, right? So we will basically use binary search or the lower bound function for C++ users to get this particular value which is greater than equals to a certain value in a sorted array. Primes is a sorted array, right? Yeah. Okay. Now, and we will be taking the difference and populate our map with food numbers for these particular differences, which I said over here, what we were doing from this particular table, right? Now the pseudocode for this particular problem would be n is from the user, array a is from the user, which is the tastiness values. Primes is the array containing all the prime numbers till a certain number or till a certain value, which we are getting from the sieve function or from pre-computation. Pre-computation. Now for each and every test case t, I am calculating nearest prime of x, right? Nearest prime of x. Basically nearest prime function is a binary search to get the lower bound, right? The number which is greater than equals to a certain number x, nothing else. Now this map is a mapping from integer to a vector, okay? This integer is nothing but difference and this vector is nothing but the positions, okay? Or the food numbers basically, yeah. And we are looping through this particular tastiness array, and for each and every value x, let us say x is a value at a certain index I of the tastiness array, we are calculating the nearest prime of that particular x, right, from the primes array. Now I am making a mapping of d minus x, which is the difference between nearest prime and my tastiness value x, and I am adding it to the map, and I'm adding the food number to the map, and finally I will be printing the second values of the map, which is nothing but the food numbers, in a sorted manner. So let me show you a C++ implementation of whatever pseudocode we discussed over here. Yeah, you can see that I have made the map. Basically, first of all, there is this test case in t, c in t, and I am applying sieve operation before going to while t minus minus, which is for each and every test case. So this is the pre-computation part, right? Okay. Now I am pre-computing all the values or all the prime numbers till n. And what is n? 6 into 10 power 6 plus 100. And this is the sieve operation, which is calculating all the prime numbers till this max n, and max n is nothing but n, which is passed from the sieve function over here, right? So this sieve function is calculating all the primes till this value. Okay, now I am making, for each and every test case, I am taking n as input, and I have made one map which is mapping integer to a vector int, which is difference to the food numbers. And I am taking input for each and every values of tastiness, and I am counting the lower bound, or basically the, what is this lower bound? This is nothing but nearest prime greater than equals to x. Okay, so this is this d function, or basically lower bound function, which is giving me this particular value, and I am subtracting d minus x basically, and I am mapping the food number to this particular value, which is the difference of the nearest prime minus the x. And then I am printing the values, or basically the food numbers for each and every differences. You can see over here that I have printed the food numbers over here, and then an endl at the end. So this was the C++ implementation. Let me run this one for the sample test case over here. Okay, so it's getting compiled. Okay, the compilation is done. You can see the output is over here. Let us remove these free open lines and move to our PrepBytes platform to submit this code. Okay, now let us submit this code. Submit code. So you can see that we have got an AC for this problem. I hope you have understood the pretty basic logic behind why we are using Sieve and how we are calculating the differences and mapping it to the food numbers. Thank you for watching this video, and keep coding.